Hello, everyone, and welcome once again to our Fronius webinar. Today, we shall be discussing Fronius inverter data and third-party monitoring. So basically, we shall be looking at how to query, analyze, and export data from Fronius devices to third-party platforms, or otherwise called non-Fronius devices per se. And to do this with me today is Byron Kutzer. Byron Kutzer is the technical sales advisor for the Southern Africa region. He is based in Johannesburg, South Africa. And then, of course, myself, Cyprian Okolo. I am the technical sales advisor for the Western Africa region based in Lagos, Nigeria. So together we shall be discussing this topic, as earlier said, and hoping you will all enjoy the content we have for you today. So let's have a look at the agenda. We shall be discussing the Fronius Data Manager and the Pilot, which are basically the two mediums of communication that are usually integrated in our inverters. Afterwards, we'll now have a look at the Fronius SolarNet. Byron will now step in to continue from this point with SolarWeb, and then have a deeper delve into the third-party monitoring and the SolarWeb API, and afterwards offer us some extra information. So let's now continue. But before we start officially, please feel free to ask questions during the webinar using the chat function. Byron and I will be available alternatively to respond to your questions during the webinar. And please feel free to give us your opinion about the content that we serve you in our webinars. Thank you. So, starting off, let's look at general monitoring and kind of ask the question of what is required to be able to achieve monitoring and, of course, communication in this regard. So first off, for communication to occur, there will definitely have to be a transmitter, that is, or the sender of the communication data or the message. There has to be a medium and then a receiver. So for this to occur, for communication to occur, basically, so these three elements are required. So that's basically what yields to the Fronius Data Manager. That is, for Fronius, is our communication device for snap inverters. So all snap inverters, for them to be able to communicate with any other snap inverter or another device, non-Fronius device, as you may put it, there has to be a Fronius Data Manager. So we just have a good look at the Data Manager, what it entails, and how communication is effected using this Data Manager. So let's have a further look into it. So, but then let's of course also note that for data managers, we can actually have two versions. The first version is the light version, that is this one. So the Fronius Snap Inverter Lite means that there is no data manager that is integrated in it. So for this case, all inverters that don't have the data manager integrated into it means that it cannot independently communicate with another device, simply put. So, but for Snap inverters with the integrated LAN or wireless LAN web server, it means that it has a data manager integrated into it and can independently communicate with another device, either another Snap inverter or a non-Fronius device independently, of course. So let's delve deeper into the data manager now. So for Fronius Data Manager, it's basically a plugin card that performs the function of a data logger, a web server, and of course has a Wi-Fi card integrated into it. So it's basically a PC board that has all these functions as listed. It has the capacity of monitoring up to 100 inverters. Of course, this is dependent on the sensitivity and the speed required for the transmission of information or data across these devices. So for a solution that is dependent on a very fast dissemination of data, this could as well go down to as low as 10 to 15 inverters per data manager. Okay, so so with the help of the data manager, we can of course visualize data via Fronius SolarWeb portal, Fronius SolarWeb app, and then of course via Fronius Solar TV. To be able to do this, it actually makes use of our open interfaces, which includes Modbus TCP, which is popularly known as the Ethernet port, the Modbus RTU, which includes basically a wire-to-point protocol. And then, of course, via the same Ethernet port, we can, of course, achieve the Fronius Solar API, of course, using the JSON protocol. Of course, using the RS485 open interface, there we can achieve connection to Fronius Smart Meter. And then, very importantly, via the digital input-output ports that we have on the data manager, energy management can, of course, be achieved. The Fronius Data Manager actually comes, like I said earlier, integrated inside the inverter, but then it is also possible to have it external, as an externally existing as a box, as you can see in this case. So this is the data manager box outside the inverter, of course. Okay, so let's look at the features of the data manager 2.0, because this is the latest version and an improvement on the previous version of the data manager. Starting off with the wireless LAN. So this is basically the wireless LAN antenna that, of course, aids transmitting and receiving of data. Next up is the Modbus termination switch or terminal switch. It's actually a very small switch, DIL switch, that is located either under or above the antenna, depending on which direction you're looking at it from. Next up is our input and output ports that can be used for programming other devices, energy management in short. And then we have our LAN bus, which is the Modbus TCP. And then, of course, we have the IP switch, which is also another DIL switch that is located just above under the LED status LEDs. So the status LEDs, these play a very, very important role, especially for the installer or the client, for easy notification of the status of the inverter. So I just did an extra to show us what these symbols here actually represent the functions of these respective LEDs. So to start off with this symbol, the antenna symbol, it basically stands for the Wi-Fi connectivity. The X here basically stands for the SolarNet connection. The world icon here, or the globe icon, represents SolarWeb connectivity. And then the check mark here represents the power supply. So the goal here is to ensure that all these LEDs are solid green. So once they are solid green, then your inverter is in very good shape. So that's why we labeled it the status LED. So it gives you the status of your inverter, both communication and function wise. So, so having said so, you might find a situation where your solar web LED here is blinking. So if it is blinking green, it means that it is either downloading information or uploading information. So yeah, that's basically it. So if you don't have a green, if you have red, it means that you have negative function with regards to the description. Good. So going forward, we have the Modbus RTU termination port, as you can see in this case. So let's now have a look at data manager communication. So via the communication, via the respective communication interfaces. So for the Modbus RTU, it implements the RS485 communication protocol. So this is basically the interface for connection of simple devices that doesn't need much of a configuration. So it is best for connection of the Fronius smart meter, the battery, and the home pilot. And how about the Modbus TCP? That is the LAN port. So the LAN port is basically an interface for the connection of IP-enabled devices, and it's best for inverter control. And I would also note here that the ports for the intercommunication between Fronius inverters, that is the SolarNet port, is obviously a TCP port. Next up is the Solar API, which implements, of course, the same LAN port. Here, this is basically an HTTP interface. It can be used for an HTTP interface. HTTP standing for Hypertext Transfer Protocol. It's best for web services, and these are usually read-only data per se. And this can of course be seen in the Luxon home automation, where this device, the home automation device, is connected via this port and is used to basically manage the power for the entire home system. Good. So let's have a brief communication overview. So basically, system data can be transferred in parallel to third-party components and to the Fronius Solar Web via Modbus TCP, Modbus RTU, or the Fronius Solar API using the JSON protocol. So JSON basically stands for JavaScript Object Notation. So, of course, so given that we have an inverter integrated with the data manager, it is possible for it to communicate with the smart meter via the Modbus RTU. Of course, communicate also with other Snap inverters or Datcom components using the SolarNet port, as you're going to see eventually. And then, of course, it is possible to communicate either via LAN or wireless LAN. Wireless LAN is, of course, known as Wi-Fi. So with that, you can be able to communicate with a router or switch. And then, of course, this is also possible to communicate via the same TCP port with the Luxon or third-party component, as you can see, using the Luxon in this case as an example. Of course, apart from the Luxon, we can, of course, communicate with the Victron color control, which, as you can see in this case, has the Fronius inverter with its feature integrated in its display. So to further give us another example of how this is possible or how this is done, we can just take a look at the intercommunication between the Fronius inverter and the Victron inverter in the case of an AC coupled solution. So here, this is the Victron VRM portal. And then this is, of course, a screenshot. So here we can, of course, see that the Fronius inverter feature is here already. It tells us this is a PV inverter. And then it is, of course, through the API query that the Victorian inverter is able to send and receive information about the Fronius inverter with its current power output, as you can see in this case. So this is possible via the intercommunication, as you can see in this case, via the JSON Solar API using the JSON protocol. So for the Modbus RTU, I just want to give you extra information about it. So using the Modbus RTU, it's pertinent to, of course, important for us to let us know that this is strictly an RS485 protocol bus. So you can, of course, put more components together without the necessity or without using a router. Once this is done, it is possible to, of course, search for components by default without any special configuration. Cat5, the minimum of Cat5 cables are recommended, and then it is possible to have a direct connection to the terminal ports of the communication ports, as you can see in this case. That's the orange connector. So just for an example, the Fronius Energy package with the BYD and the Fronius Smart Meter can, of course, be connected using these ports. So next up is just to give you extra information about alternative features. So the Fronius Data Manager can also configure the Modbus RTU interface to read data and control the inverter. It is possible. And then, of course, if the Modbus RTU interface is configured for control or read inverter data, then you can't use it for a meter, a smart meter. And then it is not possible to configure the Modbus RTU interface for Fronius Simo Hybrid for reading inverter data. This is because you would need storage and meter, because the Fronius Hybrid is actually a battery connectable inverter. So for the Modbus TCP, this is, of course, an Ethernet or wireless LAN bus. So you can use this this is used for standard networking, standard network technology. This is basically standard network technology to connect the devices. That's what it implements. And the smart devices like Fronius Home Pilot are able to be connected over this particular bus. So Fronius Data Manager easily finds a Fronius Home Pilot without configuration over the internet. And then Fronius Home Pilot via the wireless LAN can be configured using the WPS function or access point of the inverter. Then no additional configuration is needed. So as an additional feature or notification, you can activate the interface for reading the inverter data, but then it's not possible to control or read inverter data over Modbus RTU and TCP at the same time. You would have to select or make use of one of these channels. Okay, so having said so, let's now go through the Fronius Data Manager commissioning. There is a dedicated video or YouTube video that explains this process, the commissioning of the data manager. We will leave the link when we share the details, when we share the slides of this presentation. The link will be left on this particular slide so that you can easily access this short YouTube video to see exactly how you can commission the data manager. So for easy startup, in the commissioning process, first off is to, of course, open the Wi-Fi access point. So once you open the Wi-Fi access point, you now make the inverter ready to communicate. So once you go to the display of any snap inverter, please access the setup menu. Once you access the setup menu, scroll down to the Wi-Fi access point, as you can see in this case. Then once you click on enter, it would now ask you if you want to activate the Wi-Fi access point. So once you click on enter, it will, of course, now open the Wi-Fi access point and then reveal the information, that is the data logger ID of the particular inverter, and then the password. So all you need to do is to now search for the Fronius inverter. which usually the name of the inverter, of course, will be displayed. So you have to open your Wi-Fi access point on your device, and then search for the inverter. So it normally starts with 240 points, the other numbers associated with the inverter, as you can see an example in this case. So once that is done and you select this particular inverter, you would now have a request to enter the password. The password is 1 straight through to 8. So once you input that, you would now be able to, you would now have access directly to this particular inverter. So for the commissioning process, once you're connected with the Snap inverter through your smart device, you would now have to open on your web browser, input this IP address 192.168.250.181. Once this is done, it of course grants you access to the setup wizard, through which you would now be able to have access to the inverter and then continue with your configuration. As you can see in this case, it is also possible to connect via WPS. Okay, so this all you need to do is to click on the WPS button on your router, and then this will now aid a seamless connection between your router or communication or internet device and your inverter. Good. So that much said about the data manager. Let's now have a look at the pilot. Like I mentioned, we have two basically two communication medium, that is the data manager and the pilot. The pilot in this case is the communication medium for all Gen 24 series and Tauro series. Okay, so for this particular data communication interface, it comprises of LED status display. It's of course consists of a data logger, web server, and Wi-Fi card, just like the data manager. And then you can achieve visualization via Fronius SolarWeb portal, Fronius SolarWeb app, and of course Solar TV. It of course also has multiple interfaces like data manager. Have two Ethernet ports in this case, as against one on the data manager. We have can also achieve Fronius Solar API communication using the JSON protocol. It has two Modbus ports, Modbus RTU ports. It also includes the WSD function, which is the wired shutdown function. This is of course discussed in other webinars, in detail. And then, of course, we have a digital input and output ports. So for the Fronius pilot, let's look at how we can achieve access, of course, opening the Wi-Fi access point. So having a look at the inverter, a straight look at the inverter, we're going to see where the pilot is located. It comprises of three elements: the operation LED, which is located on the left-hand side of the viewer. The middle there is a touch-sensitive button, and then on the right-hand side of the viewer is the communication LED. So one quick tap on the light-sensitive button basically opens the Wi-Fi access point, or basically activates the Wi-Fi access point. Two quick taps activates the WPS function, and then one long push for about 3 to 6 seconds quits service messages, and then either deactivates or activates the key lock function. Okay, so let's now have a look at the Modbus interfaces. So for the Modbus interfaces, let's have a look at the Modbus RTU that implements the RS485 communication protocol. So for this communication terminal, it has a 10-pole plug terminals. It has two Modbus RTU interfaces as against one that we have in the data manager. So they are labeled Modbus 0 and Modbus 1. Each terminal has 12 volts pulse, and then it can be used to communicate with the Fronius smart meter, home pilot, UID, and then of course it's a SunSpec interface. SunSpec basically means that how do I put this? So simply put, SunSpec is basically a communication protocol that kind of unifies products from different manufacturers so that they can be able to communicate with each other on the same platform, simply put. Yeah. So, so for the Modbus 0 and Modbus 1, please ensure that the switches are on to be able to use that particular Modbus interface. Giving us a clearer look at this interface is we've kind of had an elaborate view of this port. So we have the control voltage, and then you have the first Modbus, and then of course the second Modbus interface with their respective supplementary or complementary terminals, as you can see in this case. So M0 plus and then M0 minus, then M1 plus and then M1 minus. So this can of course be said to be your A and B, or D plus and D minus, as most installers would want to note this communication ports, as you can see in this case also. So D plus, D minus, and then another D plus and D minus for the respective Modbus ports. Okay, so going forward, let's have a look at the digital input-output ports. So for the digital input-output ports, they consist of actually 4 input-output ports that are mostly used as output ports because we have enough digital input ports, that is 6. So in most cases, these 4 digital input-output ports are usually made use of as output ports. Say they include input-output 0 to input-output 3, that is input-output 0, 1, 2, and 3. So these ports are basically implemented for intelligently managing the load. So with these ports, you can intelligently manage your pool pump, air conditioner, charging stations for EV, heat pumps, and the likes. So this basically means that if you're producing more than you're consuming, you can actually make use of the surplus power generated from your solar unit to control all these devices. So it's a pretty interesting line of energy management process that makes good use of a surplus energy to save on tariff costs and of course on power costs. So going forward, how to configure digital input outputs. We have a dedicated webinar that is that tackles or elaborates on how to do this step by step. But then just to give you an overview with this single line diagram. So just like I explained earlier in the previous slide, if you have a pool pump, an electric vehicle, air conditioner, or a heat pump, as you can see in this case, you can, through this terminal, through this input-output port terminal, control these appliances via an external relay. So what it's done is that, of course, you have an RS-485 implemented terminal, that is a wire-to-point protocol or wire-to-point connection. So these cables actually comes to the external relay, as mentioned. So they now activate the coils of these external relays, and then the contact of these external relays now activates or powers these devices or appliances, as you can see in this case. I'm just giving us a summary on how this can be achieved. So the configuration is actually done either by power production, meaning that once there is power production on the output line, it is possible to power these devices, irrespective of what the baseline load is. And then it can also be programmed by power surplus. So this ensures that you have taken enough from your baseline load, and then once you have any surplus, then this surplus will now be used to activate these appliances. So, of course, you can define, you can do this by, of course, defining thresholds. Say, for example, if you have 3 kilowatts peak generation per se, and then your baseline load is, say, 1 kilowatt. So if you have a generation of 3 kilowatts, it means you have a surplus of 2 kilowatts. So which means that it is possible for you to actually activate a pool pump and possibly your air conditioner, depending on the threshold that you have actually set in terms of feeding or consumption. So it is also possible to have individual durations of these powered appliances. Of course, you can run them for a particular duration, per signal or per day, or a particular pre-configured duration. Good. So let's now take on Fronius SolarNet. So for Fronius SolarNet, the Fronius SolarNet is basically a ring topology that interconnects Fronius devices so that they can communicate in the same line of communication. Yeah, so I believe that made sense. So pictorially speaking, we can have it represented as it is in this case. So you can either have a data manager box, which serves as the communication medium, and then have a ring topology of even older Fronius devices. This is an IG inverter, of course, with a Fronius light inverter, as you can see in this case. Or we can have a full version of Fronius Snap Inverter, or otherwise called the Fronius with the integrated data manager, and then have a complete loop, as you can see in this case. So this means that in this loop, or in these loops, it is possible to communicate with any of these devices, of course, via the data manager. And then, of course, I would like to note here that it is only possible to have one data manager per communication loop. It is recommended that we use Cat5 cable and above for any of these loops, communication loops. Yes, so in order to achieve this, we have in and out communication loops, so communication ports, sorry. So all we need to do is to ensure that the plugs are in the correct position, and then the loops are done from the out terminal of the first device to the in terminal of the next device. So this continues until the loop is complete, and then the out stop plug of the last device is left in place. Good. So let's look at data communication via Wi-Fi. So via Wi-Fi, it is possible to communicate independently from inverters or group of inverters, because this could actually represent a communication loop or a SolarNet loop. So it is possible to communicate independently to or with a router, and then through this communication, you can be able to view the inverter data on your monitoring device. It could be a smartphone, a smartwatch, tablet, or a laptop. And then via cable, this is, of course, only possible via a SolarNet ring. So you have your SolarNet connection, as you can see in this case. And once that is done, you can now communicate with the router, and then through that, you can, of course, obtain all the necessary information about the system. Great. I hope that all the information shared so far has been interesting and very relevant for your day-to-day communication with Fronius devices. So this is where I am going to hand over to Byron to continue with the rest of the presentation. So Byron, I will hand over presentation rights to you. You can continue from here.
Thanks, Ebran. So next we'll be talking about SolarWeb. So Fronius SolarWeb has got two different accounts. So we've got our SolarWeb Free, which is for any installer or end user that wants to monitor their system. We have got a free version account. Secondly, we have our SolarWeb Premium version. So this is for installers that want to have more detailed access and features, so additional informations, as well as generating reports, for example. This is with SolarWeb Premium. For normal installers, it is a build feature, but as a Fronius system partner or FSP, you will then have Fronius SolarWeb Premium as a free add-on feature. With SolarWeb, you also get the bubble charts. So this allows you to easily view the data currently in real time of what exactly is going on with your system. So for example, with your battery pack that's running, you can then currently see how much the battery is being charged with, as well as in real time, you can see the current SOC or state of charge of the battery in the system. With SolarWeb Premium, as mentioned, you get a full display of daily characteristic curves as production and consumptions across the duration. So you can backdate your data. Let's say if you want to view data from 2 years ago, you're then able to do so. This also allows you to do customized reporting. So for different time periods, as well as different configurable channels. So with SolarWeb Premium, you can add, let's say, the current of MPPT1, for example, as well as your AC voltages. You can pull detailed reports directly from SolarWeb Premium to then export out to your client need be. You also get a permanent overview of the power consumption, especially for grid and cost balances. So if you are having an agreement that you can push back into the grid, for example, and you can then credit your client, you can then do a calculated report on how much balancing they have saved, for example. You also get a visualization of your return of investment. So what this does is it takes data pulled directly from the system itself, so its current production. You then input specific details such as the cost of the system, for example, and it helps to calculate the return on investment of that system itself. With SolarWeb, you also get your system management. So this allows you to easily manage multiple systems under one account. So you can either view it as a widget, so you can have a picture displaying each individual system, or the written PV system name to then help you manage your PV systems. With the exported reports, you can have them either exported as a CSV file format or as an Excel format, depending on which you would like to view and export data from directly. With SolarWeb Premium, you can also automatically generate reports on a monthly base or daily base, for example, to be sent directly to your client itself. So you don't have to go back every month and generate the report, for example. It will automatically export that report to your client. You also get error messaging because of an automatic energy consumption. So this helps you to compare between two inverters of each other. So you can see, for example, both MPPT trackers, as well as the current of that string, for example. You have full viewing control of any error messages. With SolarWeb, you also get the weather widget. So this is an energy meteorologically new weather widget that we have. So this helps you to view data of that exact location. So when inputting the data on SolarWeb, you can then view exactly how the weather was performing that day. If you had, for example, a separate temperature sensor or irradiance sensor, you could then also help to then generate a report valid on the accurate data that you've pulled from specific sensors. So the next part is third-party monitoring. So this is when you will then utilize your SolarWeb API. So what is an API? An API is an application program interface. So this allows the sharing of data between two applications. So in this case, it's the client and the server. So the server being the SolarWeb and then the client being the actual client's application. It will then share the data via the internet or cloud-based. So this is a server-to-server API. So this adds your solution to the system without adding additional hardware to the system. So you'll pull data directly from SolarWeb output to your API or monitoring platform that is required. So what would be required in this instance? A SolarWeb user, as well as an existing PV system, which sends data to the Fronius SolarWeb. So what will be visible? So almost all data displayed currently in SolarWeb Premium will be currently able to be output in a sense. So you can search current data, archive data, energy flow data, as well as aggregated data itself. So why would you use a SolarWeb API? So this allows customers to have access to raw data from their PV systems. This will then help you to then build your own application for your displaying of the data in a custom presentation for your client. This also helps you to create your own monitoring platforms. So exact data that you want to view, it then allows you to have that full customized capability of having your own data that you want to view always being displayed. So with Fronius, you can access to those PV systems through, although customers have the right on different platforms. So your aggregated data from multiple PV plants. So this for your real-time data, for example, and as well as your usage from various purposes. So this is just a comparison to the Solar API, which is a local API or push service on your data manager card. So this relies on no SolarWeb connection required. So this will output data directly from the data manager. So real-time data that's pulled directly from the data manager will then be output via cloud service to your API, your local API, in a sense. So how does a SolarWeb API work? So what happens is that customer's application will then send a request via the API to SolarWeb. This request will then be acknowledged by SolarWeb and then will then output the relevant data pulled directly back to the customer's application. From here, the customer's application will then read that data, and then from there you can output a readable format, such as graphs, for example, which will then help you to visualize the exact extracted data that you've pulled directly. So in turn, making a custom monitoring platform. So what are the benefits of the API? So this allows easy data integration in existing or new applications. So you can always add older systems back onto an API, for example, or any new or current systems that are coming, you can always add them onto your API. So this enables the offer of new services for the end customer. So if the end customer is wanting a individual custom-made monitoring platform, this will then allow you to do that for that customer. So APIs can be used by practically any programming language, so which makes it easy to use. And also the connection to SolarWeb. So this offers better support by Fronius if it's done through our SolarWeb API, for example. So this allows you to hide complexity from developers. So also extend your systems to partners and also make software components reusable. What are the key features of the API? So this allows you to do filtering, which is most API calls support filters, device and all channels, which reduces the amount of data. So this allows you to filter out exactly what data you want to view, for example, and allows less traffic in a sense. The next thing is the paging for large amounts of data. So the caller does not get too much data at once and makes calls faster, for example. So that entails means your data is more accurate in a sense. Also HTML error codes or JSON error details extensions. So this allows the API to provide additional information for error analysis. So you then can see exactly what that error was, for example, and helps you detail exactly what could be the solution for it. The next part is the API usage. So this is different authentication methods. So you got the regular access. So this is when the client originally owns the PV system or the client's email address is added to a PV system. So user permissions required in this sense. All the systems are connected to the account by the ownership or granted permissions can be accessed. And the other method is user impersonation with JVT or JSON Web Token. So this is when the client is able to see the PV system in context of another user. So this means that if a client doesn't have SolarWeb, for example, or doesn't have a profile, for example, they can still view the data pulled from SolarWeb to your custom API protocol that's been made. The next thing is Fronius provides secure login methods. So users' credentials do not have to be processed on the client side. The next is the interactive user interface. So it's possible for initial testing of the API without writing a single line of code. So this allows the user's interface also acts as documentation and provides more detail about each API call that's been done. The user interface or Swagger UI is embedded in SolarWeb. So this is just an example of a link to the interactive API UI. So it's API SolarWeb /third party. So what happens is this is how the output data will then be viewed. You will have to have a basic idea of writing code, and that will help with exporting the current data that you want to view, for example. So if it's error messages, for example, real-time data, for example, and what periods, you will have to have a basic idea of how to write basic code. So it's just an example, a sort of simple integration example. So your first step is to go to the local data manager interface. So for example, if your IP address is 77.117.199.93, this is how your address would look like in the browser interface. The next step is to delete everything after the IP address. So your IP address would look like the following. So it'll be 77.117.199.93. The next step is to then add the following writing protocols. So it will be the solar underscore API gen inter real-time data.cgi. So this is an example of how the address would look. The next step is to press enter. And now basically you are a software developer. So the Solar API is the request name, the question mark separator. So this is the get inverter real-time data. And the next is the parameter, which is the system name. For the Solar API, there are billing processes. So this is fully billable data plans that we have. So it's easy and detailed. The data plan is automatically chosen dependent on the usage. So if you are only pulling from 0 to 500,000 data points each month, it is a free protocol. Whereas if you're pulling over 500,000 to 2.5 and above, you will then be billed depending on the amount of data points and calls that you are providing from that Solar API. So again, touching on the pricing, so the data points versus the API call. So the amount of data is determined by the number of inverters, for example, as well as the data resolution. A user with a large number of inverters can get a huge amount of data with the same number of API calls. As a user with just one inverter, you will then see the calculation on the next slide. A user who makes only one API call per day will get more data than one making one API call every hour, for example. So it helps to make use of maybe making a call every once a week, for example, if you need that data weekly, for example. It all depends on how that data needs to be viewed. So the next part is the API calls itself. So what API calls are possible? So aggregation data, so this is your real-time data, for example, as well as PV system information. You can also do historical data, your power flow data itself, as well as any service messages, as well as your meteor data that you can pull directly from SolarWeb. So this is just API calls, so this is PV system information. So the number of PV systems linked to the user's account, so this would be the amount of PV systems that are linked, and then also the list of the PV installations. It'll also then give you a detailed information about those PV systems itself, as well as the number of devices of each given installation. So for example, it would be the smart meters information, as well as your own pilot, for example, or what pilot, depending on the system is configured. This allows you to get full detailed information about each the devices in the PV system. So on the API calls on the aggregated data, so this is your energy production and consumption data of each PV system. So you can either have the data viewed over the whole lifetime of the system itself, or yearly, monthly, or daily, depending on what exactly is required for your API. As well as historical data. So this is data points that are logged at the inverter so every 5 minutes and transferred to SolarWeb at regular intervals for a PV system or for a single device of a given PV system. So from here, you can pull data directly from, let's say, the inverter, and you want to monitor the MPPT and the power production. That is specific historical data that you can pull directly. You can also do the power flow data. So this is your real-time data from the PV system or a single device in a given system. So this allows you to view the production of the PV system, so how much PV production has been attained, as well as what power has been fed from the grid or to the grid from your system itself. So are you pushing back into the system, for example? Also helps you to view the household consumption or your loads itself that are being covered, as well as your power from or to your battery in your system itself. The next thing is the service messages on the API calls. So this allows you to view service messages or state codes or error codes for the PV system or for a single device of a given PV system. So this allows you to view, let's say you only want to view the error messages for an Eco27 inverter that's in your system, you can have that API protocol. The next API call is your meteor data. So this is a premium feature with SolarWeb Premium. So this allows you to view the weather and PV yield forecast data for that given PV system. So again, this is only possible with a SolarWeb Premium account. So again, it's data such as if it was the wind speed, for example, your radiance, your meteoric data. So in summary, SolarWeb Application Program Interface, or API, is an application-to-application interface for accessing data on SolarWeb servers. So this allows two applications, so the client and the server, for example. So the client requesting data from SolarWeb, and then the SolarWeb delivering the data back, and interacting via the API with each other without any user interface. So again, on the detailed example, so again, the client will then do the request through the API to SolarWeb servers. From there, the database will then process that data and then export it back as a response back to the client's application. So that concludes today's webinar on third-party monitoring. So for further information regarding operation and instruction manuals, for example, they are downloadable on our fronius.com website. As well as on our YouTube channel, we have our how-to or installation videos, webinar recordings, as well as our Sub-Saharan Africa playlist, which is a playlist dedicated to our webinars for Sub-Saharan Africa. Your Fronius Solar Energy team, so this is for any further technical questions, to organize trainings, sales international, and after sales service, as well as at the bottom is my colleagues in Africa that can assist. So we've got Sipin Okulu for the Western African region, myself, Byron Kutzer, for the Southern African, and then David Mongi for the Eastern African region. Thank you very much for attending today's webinar.